I think if you're going to talk about data publication on the Bitcoin blockchain, you really got to go back to the very beginning, which is quite literally the Genesis block. Block 0 of Bitcoin quite famously has this quote, the Times, 3rd of January 2009, Chancellor on brink of second bailout for banks. And, well, you can read it. It's data. It's definitely not Bitcoin transaction data. And, yeah, quite literally the very first Bitcoin block did have an example of data publication. And, even a little bit later, you get another famous example, which is the tribute to Len Sassman when he unfortunately died. And some people, again, figured out a way to go stuff this little tribute into Bitcoin. And I don't have space on the screen to go show the full thing, but funny enough, right after him, there's also Ben Bernanke from, was it the U.S. Federal Banking System or something? He's also in there too. Again, very, very early blocks. I think this is from 2010 or something, if I'm not mistaken. Maybe 2011. It's quite early. And if you want, if you have a Bitcoin core node that's fully synced, you can even recover this. I mean, that's a screenshot of one of my nodes with the strings command, which searches for strings and text in binary data, and it just displays that. And here's one that I did very early on, February 2013. This is on Bitcoin testnet, and as I said, I changed my mind about the block size debate. We have to increase the block size. Very important. If you run this command, you'll get 2 transactions on Bitcoin testnet, and you run it through XXD, which converts hexadecimal to binary, and then you play the audio. And I wouldn't really want to give away, but let's just say I'm never going to give you up. So, the bigger question, all right, is the ability to do this good for Bitcoin? Should I be able to rickroll the blockchain? Why are people doing this? Can we stop this? And, as much as ordinals and inscriptions and all this got a lot of debate now, I want to stress that this is something that's being debated for very early on. Even in 2013, we were already talking about data publication. And there's a lot of different ways to go look at it. I can certainly go talk about why people are doing this. And frankly, 3 examples I gave, one of them actually has a technical reason, which is the reason why the Genesis block has that quote, is to go prove that Bitcoin was created after a point in time, which proves that Satoshi wasn't pre-mining it. And, that's all well and good. It's a bit of a specialty thing. Certainly, rickrolling the blockchain is a bit of fun, and, you do that because you can. The tribute is, again, a bit of fun, and you do it because you can. But, there are technical reasons, too, and there's a whole variety of them. So I think the bigger thing to say is, there is incentive for people to put data in Bitcoin blockchain. And those incentives come in a whole variety of different ways. But, in decentralized systems, you really got to look at, well, what can you actually do? Can you go stop something? It doesn't matter if, trying to go argue to people you shouldn't do something. If they want to, they will. And to address the can we stop this, well, let's go look at that Len Sassman tribute. How did that actually work? Well, this is the actual script from a pay to pub key hash address way back in the day. And if you're a little uncertain about how Bitcoin works, to recap, remember transactions, they have inputs and outputs. And the outputs determine what situations is a coin allowed to be spent. That's called the script pub key. Bitcoin has a little scripting system, it's a little mini language, and that mini language has opcodes, like dupe something, hash it, push some more stuff to stack, verify, and so on. And then the inputs satisfy these outputs. So in this particular case, with that Len Sassman tribute, they were using fake Bitcoin addresses, Bitcoin addresses that weren't really derived from pub keys. And that's what it looks like on chain. Now, from a programming point of view, the question is, well, how do you go and distinguish between a fake Bitcoin address and a real one? And the truth is, in this particular way of data encoding, it's exceptionally difficult. I mean, it's just data, right? If I tried to go write a filter to go block this, I mean, how am I going to determine is it a hash, is a attribute or not? The only thing anyone's ever come up with that has any chance of achieving this goal is an idea from Greg Maxwell, which is to say, what if we redesigned Bitcoin scripting so that every single time that you push something to the stack, you had to go prove what it was? And with hashes, you can actually do this because you go and prove the preimage of the hash. And in this, the case of this, you could go have a preimage being, well, I've now proven it's a pub key. But fact is, we never did implement this, and the time to do this would have been in 2012, 2011. Right now, hundreds of different Bitcoin wallets are out there, and none of them support this functionality. So the truth is, there really is no way to stop this. But you can make it more expensive. And that gets down to the other approach, which is to think about harm reduction. And the first and foremost thing I'll talk about is the difference between UTXO space and block space. Now, remember, going back to, I talked about how does a Bitcoin transaction work? You have inputs, you have outputs. Well, in Bitcoin, we have something called pruning. And the idea behind pruning is if you have a node and all you want to do is validate new blocks as they come in, the data that you need to do this is not all of the historical data. It's the set of coins that at this moment are unspent, because valid blocks only spend unspent coins. And that is called the unspent transaction output set, UTXO set. So every single node in existence, if it's fully validated, has to have the UTXO set. There are ways around this, which I can get into in a second, but with current available technology, if you want to have a full node, it's got to have at least a UTXO set. And pruning lets you run a full node on a lot less space. I personally run, maybe 10-ish nodes for various reasons. Out of those 10, probably like 3 of them, of those 10, 3 of them are archival nodes that have the full blockchain. The rest are run pruning just because it's a lot simpler and faster. Also, the other thing with the UTXO set is that when a new block comes in, the speed at which you can validate that new block is in part determined on how fast can you access the UTXO set. Now, it's a common myth to say that the UTXO set has to be in RAM. It doesn't, but it's certainly a lot faster if it is. So the more of the UTXO set that you can store in cache memory, the better. And that gets down to, well, what does data publication do? The data publication mechanisms that put data in the UTXO set, they are, and have been for many years, considered to be undesirable because that adds to the burden of data that everyone's going to have to go and store. And this also gets down to the dust rule. Well, what is the dust rule? Now, by the Bitcoin consensus, a transaction output is allowed to be of any value, including 0 satoshis. On Bitcoin, you are allowed to create a transaction output that has 0 value. And you can spend a transaction output that has 0 value. It's perfectly allowed by the rules. But we have this notion of standardness, which is say, while we allow all these things in the Bitcoin protocol, we limit what's considered to be standard with standardness rules, and those are the only transactions that will propagate around the mempool. So, your mempool will only accept things that follow the standardness rule. And part of the standardness rule say, well, hang on, why are we letting people create transaction outputs that are so small that it would cost more money to mine them, to mine the transaction spending them, than you would actually get back? That dust rule says, well, so-called dust, very, very small amounts, we're not going to allow it. We're going to reject it from our mempools. If a miner chooses to mine it, that's great, but we're not going to participate in that. And, the dust rule in this case does make things like that Len Sassaman tribute more expensive, because you got to spend enough Bitcoin to go and meet that dust rule. But again, can we stop this? No. And we certainly can't stop people from mining blocks. Where is it? Two back. There. That rickroll I did, I mined that testnet block myself. In fact, the code I used to do this, I just went and hacked the Bitcoin Core code base and made it put that entire rickroll song in the Coinbase output. And I did that because I wanted to make it easy to go play because it would be funnier that way. But miners can go do these things. Standardness rules kind of prevent this a bit. And then there's another bit of harm reduction that we did, which is something called op return. Now, way back in the day, op return was a very screwed up feature of Bitcoin, which allowed you to instantly return from a script with any value you wanted. And funny enough, this actually let coins get spent, get stolen really due to some other features of script. But that got fixed. Now op return says when a script execution hits that, op return says that script fails immediately and we're done. Well, if you see a script pub key starting with op return, the Bitcoin Core consensus can say, hang on a second, I know that's impossible to spend. There's no possible way that coin can be spent. I don't even need to add it to the UTXO set. And that data that follows that op return can just be ignored, and that's that. And op return was standardized as a type of standard transaction specifically to let people publish small amounts of data in the Bitcoin chain. And I think op return got added 2013-ish so. Yeah, maybe 2014. Someone can look that up, but approximately then. And that was kind of when these compromised. We said, well, if you're going to put data in transactions, use op return. Of course, there was kind of a bit of a patronizing fight about, well, how big can op return be? And in the current, when it was introduced, it was limited 40 bytes. That could increase 80. There's a bunch of debate around there. But the thinking back then was, well, we'll try to push people to go do the right thing. The right thing being design protocols that don't need all this data. It's good for all of Bitcoin. And, there's a lot of debate about that. But over time, though, this got loosened a bit. And P2SH is interesting. So, again, how does Bitcoin transaction work? You have a script pub key. The script pub key is instructions you have to go satisfy to let the coin be spent. Well, we kind of got a bit clever. We said, hang on a second. Why do we have to have the instructions in the script itself? Why does this need to be in the UTXO set? Why don't we put it somewhere else? Why don't we let the wallets hold on to it? So P2SH stands for pay to script hash. So rather than paying to a script, you're paying to a hash of a script. And now that hash is in the script sig part of the transaction, the inputs to a transaction. So basically, if I have a coin with P2SH, I say that coin can be spent if someone publishes a script that matches this hash and provides the rest of the instructions and satisfies that script. Sort of a two-step process. Well, what does this do for data publication? Well, part of P2SH was now that we have this way of putting scripts in the right way and fixing some other problems with the Bitcoin scripting system, well, we can get rid of the rules. Now remember, standardness was very prescribed. It used to be to say Bitcoin transactions, the script pub keys could only be in certain formats. P2SH allowed us to basically remove all these rules. And that allowed me to write publish text.py, which is a tool that comes with my Python Bitcoin lib library, just as an example. And it publishes arbitrary text in the Bitcoin blockchain. Well, how does it do this? By creating P2SH outputs that, to be satisfied to spend, require you to publish chunks of text onto the stack, thus in the inputs of the transaction. And all of this is locked with signatures and hashes and so on in such a way that other miners can't mess with this. And then I also am a little clever, which is I figure out how long each line of text is, and I pad it to a sufficient length that strings tool I showed earlier can find it. And long story short is with all this, you can go to a website bitcoinstrings.com, and it will actually show you all of the texts that people publish in the Bitcoin blockchain. And this is kind of interesting because now we have a way of easily publishing text and other people easily finding it. And sure enough, that has been used for a bunch of stuff. A lot of it just vanity. Someone's uploaded, megabytes and megabytes worth of IRC logs from Bitcoin Dev to the mailing list and so on. And, that kind of got some attention. Someone, not using this tool, but using some different tool, actually even published the bitcoin.pdf file, which, funny enough, is now mentioned in a lawsuit from Craig Wright against me and a bunch of other devs saying we're infringing on his copyright to the Bitcoin PDF file. Unfortunately, in this case, that lawsuit isn't going to go very far because it's pretty clear that that PDF is MIT licensed. But, you can see there's potential issues here. But, it is what it is, and at least up until this point, things weren't that interesting. Again, a bunch of people publishing text, but, in other things, but it hasn't been so interesting. So, now we get to inscriptions. Now we have a nice website, ordinals.com, and it shows all of the inscriptions people have put on. Well, all right, let's roll back a bit. What are inscriptions and what are ordinals? So, ordinals is this, frankly, kind of kooky scheme to name every Satoshi. And it's sort of an algorithm where you take a transaction, you can track the Satoshis coming in and the Satoshis coming out. Satoshis being the smallest unit of Bitcoin. Frankly, I think ordinals is nuts. It's like stamp collecting, but for Bitcoin. Although even more obscure than stamp collecting. Ordinals has the idea that, some ordinals are more rare than others and so on. And ordinals itself didn't really catch on. But inscriptions, on the other hand, they did. And inscriptions are a way of publishing data assigned to a particular ordinal numbered Satoshi. In particular, publishing images. So how does all this work? Well, remember that with P2SH, like I explained before, there's nothing stopping you from taking an image, encoding it into a script sig with a P2SH pub key, that to spend that pub key, you must publish that data. Now, there's some technical limitations on this, which is P2SH, due to how scripts work, you have to go fragment it into 512 bytes chunks, et cetera, et cetera. But honestly, none of this stuff really matters because code is what takes data from Bitcoin transactions and turns it into something we can see. There's code that took all of those images and decoded them. Exactly how those images are encoded really doesn't matter. Now, inscriptions takes advantage of some more recent tech than P2SH. First of all, SegWit. SegWit was an upgrade to Bitcoin protocol, which went a step further than the sort of script sig, script pub key difference, and said, well, hang on, why don't we do a few things, but one of them being, why don't we go take the scripts and put them in a separate area, which will make the blocks bigger. And this gets back to the block size wars. We had a compromise where we made blocks bigger by taking all of that script data and sticking it into another place. Well, because that other place is guaranteed to not be in the UTXO set, we also said, well, it can be discounted, right? The cost of a script is significantly less to the Bitcoin protocol than the cost of UTXO. So data in scripts with SegWit is about 4 times cheaper because it's counted less, basically. And then finally, Taproot came along, which is yet another upgrade to Bitcoin scripts. And basically, Taproot is just a way of rearranging Bitcoin scripts so that you can commit to a very, very big script with many different possibilities, but reveal only one of those branches. This is good for things like multisig, where you might say, well, I have 50 out of 50 people who can pay this in different ways. Let's commit to all the different combinations of this to figure out exactly how the heck, 40 people out of 50 paid. It's very useful, but in the case of inscriptions, they took advantage of the fact that with Taproot, we truly removed all the all the restraints on Bitcoin scripts. We allowed them to do whatever they wanted, basically. And that's because we fixed a bunch of issues that used to plague the old scripting system. And in particular case of inscriptions, they wrap the data around an if statement saying false, if, all this data, end if. And that false bit, combined with if, just says, all right, just skip past all this. It's all stuff we can ignore. And that lets you, in one easy way, go put a bunch of data. But again, nothing here is really novel. But it certainly gets a lot of attention because people start doing it. Well, why do people start doing it? Well, probably because the marketing was done right. Because it had a nice website. Because somehow it got attention. There's no one easy answer to this. But people started putting enough inscriptions that block fees started going up. And that led to the backlash, which is this guy, I think, is the most unhinged version of the backlash. And he started the ORD disrespecter movements and ORD slow nodes. And, well, what is all that? Well, ORD disrespecter is just a patch that targets the exact way that ordinal nodes, ordinal inscriptions are encoded to say that they're no longer standard. So if you run the ORD disrespecter patch, your node will just reject those. ORD slow goes another step and says, well, if you see a block, if your node sees a block that contains an ordinal inscription, you will hold that block for a short amount of time, maybe 30 seconds, maybe a minute, and then broadcast the block on. And the idea is this will, screw over all the inscription people. Well, it certainly made a lot of impressions on Twitter, but an interesting question is can this actually work? And what this really comes down to is a question of censorship. Now remember, Bitcoin is a flood-fill network. Every node is connected to other nodes. And those nodes gossip things. They go tell people, different nodes around them, one after another. And the question of gossip in a flood-fill network is what's called a percolation problem. This comes from studies of soil, actually, which is if you have a bunch of soil, given how dense the soil is, will water flow through that soil? Well, will information flow through a network? And I'm going to try a little experiment here, which could be kind of interesting. So I'm going to tell one person of the audience a color. And I want that person and everyone else in the audience to, if they hear that color, tell their neighbors, if and only if the year they were born is divisible by 2. That is, it's an even year. So let's go try this out. This could be interesting. Tell your neighbors. And tell people behind you, too, not just in a line. If you hear the color, if your year you were born is divisible by 2, tell your neighbors behind you and around you. And let's see if it gets to the other side. Otherwise, you don't. Yeah, it's divisible by 2. So, and basically, this simulates a flood-fill network where 50% of the nodes are censoring, right? Approximately half of you are going to go say. And by the math, this may work, it may not. Now, Bitcoin, the way Bitcoin nodes work is they are much more gossipy than you guys. Every one of you is, in fact, this kind of a sparse audience is probably surrounded by 4 people or so. And Bitcoin nodes, at minimum, connect to 8 peers plus another 4 for blocks. So by the math, if I'm lucky, 50 is kind of on the threshold. If I'm lucky, this might have made it too. Now I'm curious, how many people actually had a color told to you? Put up your hands. Let's see how far it went. Okay, propagated reasonably well. Now, curious, so how did it not propagate across the side? Yeah, across you guys. You didn't hear? Interesting. All right, so, yeah, interesting. Well, I mean, in this case, it's kind of right on the edge. So it propagated like half a view. And this is kind of like ordinal, the OR disrespecter nodes getting like 50% adoption. Now, another question is, well, how many of you people actually run nodes? Let's put up your hands. All right. How many of you people run OR disrespecter nodes? Yeah, all right, one lonely guy. I hate to say this, but you're probably achieving very little because censorship is hard. And, it's not impossible, but it's hard. And an issue here is, well, money. Like, Ordinals, for some reason, has been able to get a large amount of money behind it. And that money incentivizes people to do things. For instance, if I wanted my color to go a little further, I can start running my own nodes, my own interconnections, and making sure that people actually spread this. And there's nothing you can do to stop that. I mean, you can't easily stop me from running a node. You can't stop miners from peering with each other. So, why are there still inscriptions there? Well, basically because the OR disrespecter node thing hasn't really had very, very much success. It's nowhere near popular enough to matter, and even if it was, people bypass it. So with that, let's go talk about fees more generally. So remember, all of this data publication, this is demand for block space. People want to do things with Bitcoin, they want to use up transaction space, and they want to get their transactions mined. We've even seen with inscriptions, people are willing to pay miners directly in some cases to make sure that their transactions, like people are willing to pay directly to miners to make sure that non-standard transactions get mined. This is how we actually got Luxor Pool mining the biggest block in Bitcoin's history, because some guy thought it would be kind of cool to go make a ordinal inscription that filled up an entire block. And they worked with Luxor Text. My understanding is they sent them an email and said they're willing to pay a few $1,000s to do this. Now, because Bitcoin mining is a competitive environment, you are competing with those people. And this is why fees went up when ordinals suddenly became popular. The bigger question is, well, what is Bitcoin for? Like, what maintains the value of Bitcoin? Because remember, demand for block space is not the same thing as demand for Bitcoin. There's a whole culture of hodling, which doesn't even use up very much block space at all. Yet there's also people who want to go and buy coffee for Bitcoin on chain. And I think basically what you can say is the fee market prices certain things out. Now, of everyone here who went and bought a drink, my understanding is basically all of you would have used Lightning right now. I'm not even sure if there still is an option to pay on chain here. There was, previous years, but these days I can't imagine any of you are buying a $5 drink with $1 transaction fees. But that pushed things over to Lightning. Of course, another side of fee economics is we have to reward miners somehow. And as I've argued in other talks and other places, well, inflation is a good way to go do this. But certainly, if demand for things like ordinal stays up, that is a way of paying for this. But another aspect of this demand is, well, how do people publish data exactly? And what does that even mean? And again, I showed you that ordinals.com, whatever, website earlier. The image I showed you was actually of the very first inscriptions put in. This is what's happening more recently. And the recent fee bump, where demand went through the roof, that was not driven by people putting JPEGs on Bitcoin. It was actually driven by people putting tiny little snippets of text, quote unquote, minting their assets with what's called BRC20, which is like ERC20 on Ethereum, but on Bitcoin. And if you look at these assets, I don't know about you, but I think vast majority of them look like total bullshit. like straight up pump and dump schemes with absolutely no redeemable value. I have a hard time even figuring out what any of these assets are for, frankly. It looks like it's just stuff people have conjured out of thin air, and it looks like the marketing of this is mostly, well, you get in for this pump before other people get out. But from a data publication point of view, what's notable is the amount of data published per inscription has dropped dramatically from, potentially megabytes or at least kilobytes of image data to, well, that's what, 50 bytes? Little thing, a bit of JSON saying, mint like icon, whatever the heck icon means. And in fact, we can go even further. Like the purpose of BRC20 is financial assets. It's not to publish human recognizable data in the chain. And things like RGB can take advantage of this and do the same thing with completely normal Bitcoin transactions. RGB is basically uncensorable. So I think what I'll say is if you're worried about data publication, you have to accept the fact that people can use Bitcoin for non-Bitcoin things. And there's nothing we can really do about it because the tech exists to make this uncensorable. So with that, thank you, and let's get some questions.
So storm in a teapot, basically. Anybody, you're fucked.
I mean, that's why we have the fee market. I can outbid all these people if I want to.
Cool. So first question, definitely got one here. No.
Or did I just explain everything?
Wait.
Which color was it? The color is...
I think I said green or blue or something. I forget now. Frankly, I was banking on the fact that, I didn't want this to turn into a reliability experiment, because frankly, if you thought you'd heard a color, that was close enough. But the important thing was to go see, how far it actually propagates. And mathematically, on a grid of adjacency, 50% is like right on the edge. Sometimes it'll work, sometimes it won't. If I got my percolation theory correct. As you add more, the chances, of course, go up dramatically. And in my earlier full RBF talk, I mentioned the inverse of this, which is the sort of the anti-censorship problem of how do you have enough interconnections that things reliably get from one place to another. And with full RBF, a naive way to go do that math basically says that it's like 50-50 chance of things propagating at 20% of people running this thing that propagates transactions. Well, but of course that's on Bitcoin, where there's 8 interconnections at least.
So what do you think is going to happen? We can't stop data publication. What data publication uses do you expect to see over which time frame?
Well, I mean, inscriptions is an interesting example because of how pump and dump it has been, right? If you look at Bitcoin fees, they're this enormous rise, and then quickly they fell again. And they probably stayed up for maybe 2-3 weeks in the first round of interest in inscriptions. And that round of interest was in publishing, all these artistic inscriptions. Although how artistic they are is really a question of what you think. I don't think many people would necessarily say there's much value in them. And that's why the interest waned. And again, this more recent pump seems to be like an even more pure version of this pump where it's just tokens. I mean, I haven't found anything indicating that anyone's used a BRC20 inscription token for something representing something in the real world. There's no equivalent to Tether on BRC20.
Okay, but do you expect it to go in that direction?
Well, I think the issue is, I missed the talk earlier, but on RGB, but tech like RGB can scale if you design it that way. And I mean, this gets back to, what is the psychology of inscriptions? I think part of the reason why inscription was so loud, so aggressive, so inefficient was because it got attention. And if you're trying to do a pump and dump, you want that attention. You want a whole bunch of, quote unquote Bitcoin maxis yelling on Twitter about how evil all this is and how you got to stop it. That's what got the attention that drives the pump. Frankly, if Bitcoin people had just looked at inscriptions and ignored it, I don't think anything would have happened. You would have maybe had a little bit of interest, but it would have petered out pretty quick.
Okay, but so we have a price of finalization, and we stack on top of that additional price of finalization.
Well, so
over a course of time. Just allow me to.
Here's the thing. What you talk about finalization, which is correct, but the thing to recognize is with tech like RGB, the price of finalization for a very large class of use cases can be essentially zero, because you can, with something like RGB, or by closely related proof marshal work, you can commit to literally billions of transactions per second with one single Bitcoin transaction. How do you do that? Well, Merkle tree is the solution to everything. But you do enough Merkle trees and shard things, the data doesn't need to go on the chain directly. It can go indirectly, which means all this demand for finalization can be met with very little block space.
Which is essentially a scaling solution.
Yep.
Okay, so I guess the question that I'm trying to ask you, Peter, is, do you anticipate us living in a world where the finalization of data at a minimal cost is going to be a large percentage of what ends up not being on the chain, so to speak?
I mean, the thing is, it's very hard to predict because the tech exists to make this stuff scale. Another example that's working in production is it used to be there was this idea that a significant chunk of Bitcoin block space would be taken up by timestamping. And I tell you, and this was something people were discussing back in 2012, 2013, 2014.
You have your running implementation of that for...
Well, and more importantly, my implementation of that uses one Bitcoin transaction for the entire world's timestamps. 4 actually for technical reasons, but it's basically nothing. And all it required was some technology, throwing Merkle trees at the problem to make it scale. Now, let's say you had a use case where you needed to timestamp stuff and it was really, really important. I mean, maybe to give a very concrete example, let's say you were in charge of the upcoming Guatemalan election and you wanted to go show that certain election data had been timestamped. Well, that might be a use case that's important enough that you might do your own timestamp transactions because, $100 on fees really doesn't mean much when it's $10,000 worth of people's time to even set the system up. But those kinds of use cases, they only exist because of sort of inefficiency and where supply and demand prices them out. It's hard to go predict. In that example is something I'm actually working on. And when they came to me saying, "Oh yeah, we want to run some open timestamps calendars to do this," well, I mean, first of all, notably, they were already not doing one timestamp transaction per document. Even though it was a very important project, they weren't crazy enough to do that. That was unnecessarily expensive. So they used existing software to scale. But even in that case, I may have convinced them to not even bother running their own calendars because they might as well just use what other people are doing. It still works as well.
So my essential question is that we live in a world where notarized data lives in MySQL databases that are in various silos, which have various permissioning procedures for using that data to prove provenance or an event in time in terms of legal action and enforceability. And you're making it very clear that we now have the tech to make that data available to those who it is that want it at a marginal cost, right?
And that's why it doesn't necessarily drive Bitcoin chain demand. It purely depends on these very subtle economic and psychological arguments about use case to use case. It's kind of like Lightning. I mean, with Lightning, I can go buy my coffee for a marginal price of essentially 0 Bitcoin transactions. Now, there is some inefficiency. If I use Lightning in a custodial way, at some point I must have done one Bitcoin transaction to set up the channel. Although in future we might be able to reduce that with some clever techniques. But certainly one is true now. But how often I actually do a transaction really depends on exactly what my budget is, exactly what I'm doing, and as prices go up because of demand, I can quickly change things. You know, when fees spiked, I didn't do any Lightning channel opens. I just waited a bit and used the ones I already had. You know, lots of people did that too. You can actually see the graph of publicly known Lightning channels, and of new openings, they suddenly dropped while fees were high, and they started increasing again when fees dropped.
Cool. So I'll ask a final piece of the puzzle for me, intellectually. Would it be fair to say that you are a proponent at this point in time that Bitcoin's trustless nature is not threatened by any type of data publication?
I'm not going to go that far. Well, and remember, I do have a lawsuit against me that is in part about data publication. You know, this Bitcoin.pdf copyright claim is very real. It may be a pile of bullshit, but it is a real lawsuit against me in the UK, and I'm one of, I think, 15 other devs who are defending on this, and that is one of the claims. It'll probably be one of the easier claims to knock out of court, but that is a threat. Certainly, you could imagine, like, maybe the people who own the copyrights to the Rick Astley song never going to give you up. Maybe they're going to try suing me for publishing it to testnet.
Okay.
Maybe they'll try suing everyone running testnet.
So if anybody has a question, please just interrupt me, because I'll just continue going on like this as long as I can talk to you. So
I guess the thing I would stress more is it's not so much that it's zero risk. It's that with current tech, it is exceptionally difficult to stop. And even like I remember earlier I mentioned Greg Maxwell's clever hash preimage thing, where you'd be proving what every bit of data was. Even in that case, you can still upload data, still publish data in the chain, because you can brute force hashes to get a few bits out of each one. And if Bitcoin is vulnerable to a legal threat of my copyrighted data is in there, well, someone who wants to screw over Bitcoin can just spend a bit more money and still publish that data and still do lawsuits for no good reason. Like, that's just not an avenue we can easily stop.
So I want to bring it on steer the conversation a little bit. I'm sharing a room with Cashew at the moment, and we were talking last night about that we've actually literally lost developers, a good portion of developers, because of just said, okay, the legal threats and whatever, that's very real. So how are we going to mitigate against those continuations? Are you saying,
In the long run, all you can really do is hope for reasonable laws or ability to evade them. I mean, it's the same with the rest of Bitcoin. Tomorrow, governments could go say, well, you know what? We're going to say that writing Bitcoin software is illegal now. And you have to fight this politically, as well as fighting it to the extent that you can evade the law entirely. And I think data publication in the Bitcoin chain is just another example of this, where the nature of it in a decentralized system, like, we have no ability to press a button and say that data is deleted. Like, we just can't do that. That's not how Bitcoin works. We certainly can't prevent it from being published in the first place. So we have to accept that. Now, we're not the only entity like this with this problem. Certificate transparency is a good example, where the reason why to back up a bit, certificate transparency is the system where every HTTPS certificate is published in what's effectively a blockchain, multiple ones to be exact, to ensure that anyone with a website can go to those blockchains and verify that only the certificates that they wanted published were published, and only the certificates they wanted issued were issued. Well, that means you have to have the system of publishing data, and you can put data into the certificate transparency chain, and you can retrieve it. Thus, I can use it to publish data. Now, as far as I know, no one's written a tool to do this, but there's nothing inherently stopping it. People could put certificate transparency chains in a position where now they have to start censoring, which destroys the whole value of the whole system. Well, if I were them, I would look at legal options. I wouldn't be looking at tech options because the tech doesn't work that way.
So you expect to spend a good portion of your time in court for the foreseeable?
Nah, we have lawyers for that.
Well, no, but I mean...
but I mean,
to which
Craig
degree?
Wright has 2 lawsuits against me and other devs, and you know, he can just keep funding this indefinitely. And as long as we have people paying lawyers, we can mostly ignore it. But you know, this is just a threat that exists, and I mean, this isn't unique to Bitcoin. Like all open source software has this problem, but this is separate from the data publication issue.
But my question about it is. Aside from core devs, in attracting new developers, do you think that this is an issue? I mean, is that in your personal experience that we have an issue in attracting developers to Bitcoin as a result of potential legal threats that are in the mind share of people?
Potential legal threats, yes. Legal threats specifically related to data publication is pretty low on that list. But certainly in general, like this is an issue for all open source software. Bitcoin happens to be a target more than others, but you know, it is an issue, and unfortunately, it's just not one that's easy to solve with tech. Cool.
So, I'm sorry for monopolizing the conversation with Peter. It's so interesting for me. We have another good 5-6 minutes.
I apologize if I butcher the terminology, but with the Luxor mining a block with one single transaction, I believe, and a JPEG attached to it, and they had a great discount with the witness discount. Can you see in the design of the protocol that would need a transaction of that size, or is it potentially considered like an oversight that one script hash, or whatever the correct terminology is, needs that much discount?
Well, so I think this question is really about, is it an oversight that we allow this? And I can go say, based on, you know, looking at the Taproot discussion, looking at the P2SH discussion and so on, that it's not an oversight in the sense that we didn't predict that people would do this. And I think the reason why the code was written this way and the protocol was designed this way is that it doesn't, like, the difference between putting all that data in one script sig versus splitting it up over multiple ones or even multiple transactions is really meaningless. You know, all you can do is modify the cost to publish data, and without impacting, you know, quote unquote legit use cases, we can't change those costs very much. So with Taproot, the decision was made that because Taproot fixes a bunch of DOS attacks in how Bitcoin scripts used to work, you know, one example being you could go and cause script validation to repeatedly hash the transaction over and over again, potentially, you know, gigabytes worth of hashing for one transaction. Those kinds of issues were fixed. So the decision was made, well, why don't we just release it without any real standardness rules? You know, you can do what you want according to what the protocol wants. And, you know, did that make it a little easier for inscriptions? Go publish a, you know, 4 megabyte inscription? Sure, but not meaningfully easier. I mean, you know, a good example being like my Rickroll, I happened to split that over 2 different blocks because it's bigger than the block size limit. Did that stop people from extracting that transaction and playing it back? No. It was still basically just as easy because code automates this. You know, I give you one command line to type in that consists of 2 separate get raw transactions, but it still all works. And if we'd say set the limit for scripts to be, you know, maybe, you know, 5,000 bytes or something, well, you'd just go split it up into 5,000 byte chunks. No big deal. You know, my published text thing, it splits up text into at most 520 byte chunks. It still works.
Cat and mouse.
Well, sometimes playing cat and mouse isn't even worth it.
Thank you so much, Peter, for coming and spending your time with us today.
Thank you.